For this video, I'm going to discuss another Numpy array manipulation example problem. I've done one of these before. If you haven't checked it out, I'd recommend checking it out. It's on my channel. It'll help you get a general overview of the idea because this one is a little more complex and involved. So particularly if you're new to Numpy, I'd recommend watching it. Anyways, we have these two arrays here, A and B. This is what we want to output. I'll go over the sort of patterns that show in the output, but I'd recommend taking a pause at this video and just looking at it yourself and kind of formulating and kind of seeing how A and B combine together to make this output. All right, so what's happening here is the columns of A are the columns here. So A1, A5, A9 is A1, A5, A9 here. And then we have A13, A17, A21, which is this column here, which is now in the second element of the zeroth axis. Now, the zeroth axis is this outer one out here, and it's what makes this array here 3D. In B, because B is 2D, the zeroth axis is just the columns, essentially. It's the elements through the columns. All right, so that's the pattern. So then we have A25, A29, A33 here. And you can see that the second column, or all the columns here, they repeat with the same pattern in this one as well. Another way to look at it is A1, A13, and A25 are all in this first element here. And then A5, A17, A29 are all in this second one here. And then A9, A21, A33 are all here. And all the elements here, it repeats with the same pattern throughout this output. So we have A2, A14, A26, and that's in this first line here. And then A6, A18, A30, that's these values here. Anyways, that is the pattern for A's, but now let's look at B's. All the elements here, all the summations, it's using the same values of B's in this first column here. So we have B1, B5, B9. That's in this first element here. That's in this element over here as well. And it's in this element. In all the elements in this column, it's all to do with B1, B5, B9. And this second column here, that's all B2, B6, B10. And B2, B6, B10 are all along the summation here. And it repeats for the rest of these. That's the way that I'm kind of visualizing the pattern. Obviously, it will be a bit different the way that you're visualizing it. But it doesn't really matter how we visualize it. We're just going to construct kind of a step-by-step way to get the result. And, you know, like I said in the previous video, there's so many different ways to do this. I'm going to show you one method, and I'm likely going to actually make another video for a different method of doing this same problem. And that way that you can kind of compare the two and see that there's many different ways to do this. All right, so let's look at, okay, so these are the arrays. We have A, which is the same as this one here. I just haven't written the letters here, so it's just the numbers. Then we have B. Let's import Numpy and get this. And we'll look at the shapes of both. All right, so array A is 3 by 3 by 4. And the reason for that is because it has 3 elements through the zeroth axis, which is each of these 2 by 2 sections here, each of these blocks, each of these layers, however you want to view it. And then it's 3 here because it has 3 elements through the column. So it has 3 rows essentially. And then it's 4 here because it has 4 columns. It has 4 elements through each row. So there's different ways of looking at it. You can kind of say there's n elements through each axis, or there's n elements in each axis. And I prefer looking at it through because that just makes more sense. Like we have this one and it refers to how many elements through axis 0. And then this one is how many elements through axis 1, which is the column. And then this one is how many elements through axis 2, which is the rows. And then B, axis 0 is now the columns because it only has 2 brackets here. So it's 3 by 4, there's 3 elements through each column and there's 4 elements through each row. All right, and this one here is the output. That is what we want to construct, and what the output is here is just these expressions. If you run these expressions, a1b1 plus a13b5 plus a25b9, you're going to get this value here, which is, what is it, 1 times 1 plus 13 times 5 plus 25 times 9 in these arrays that I've created. This is the output that we want. If you run, like I said, if you run these expressions, then these are the outputs, these are the values that it creates. Why I've written this is so we can compare the output that we've created to this value here. And we can just use a function for that, numpy array equal, and then we can see if we've got the right response. Yeah, all right. This is the way that we're going to do this. Again, I'd recommend taking a brief look at this, like pausing the video and taking a few minutes just to go over this and get your understanding of what's happening here. Because the way that I explain it might be different from the way that you would intuitively understand it. Or it might be similar, but regardless, you're going to get a better understanding if you look at it first, briefly, for a few minutes. You don't have to look at it too long. You can write down some intermediary steps, if that helps, and then listening to my explanation. Okay. These values, okay, so actually I'm going to tell you what we're going to do first. This is the output that we want. That's what we want to construct. With this method that I'm going to show you in this video, we're going to create each of these four columns here, and then we're going to combine them together. Or actually, that's what we're doing in this first section here. We're going to do it a little more efficiently in this second block here. But that's what we're doing in this first section. Each of these columns are just these values here, so I've just replicated them. And essentially, if we construct each of these four columns, we could combine them, we could stack them or concatenate them. Numpy has functions for those, to construct this output here. What we're going to do instead is, firstly, we're going to look at this method here, assuming that we're going to stack them together, but then we're going to cleverly combine it together so that we don't actually have to stack it together. So you could do it this way. You could just construct these four and then stack it together, but we're going to do it a slightly different way. Let's take a look at this first one. Notice that these are all dot products of two vectors. Each of the elements through the columns are dot products of two vectors. A1, A13, and A25, that's the first vector. And the second vector here is B1, B5, B9. If you take the dot product of the two, if you don't know dot product, it's the summation of the products of each elements in each vector. Essentially, that's this first vector here, A1, A13, A25, and then dot producted, well, however you call it, with B1, B5, B9, that's A1 times B1 plus A13 times B5 plus A25 times B9. That's this first element here. Now, this second element here is the same, except it's with A5, A17, A29. That's this vector here. This third one is A9, A21, A33. And now what we do is we take the dot product of all those vectors, A1, A13, A25, downwards, all these rows here. We're taking the dot product with the same vector of B's, which is B1, B5, B9. Now we could do each of these three dot products and then combine them to create this this array here, but we could use matrix multiplication instead, which is essentially multiple dot products together. So this is a symbol for matrix multiplication in Numpy, by the way. The way that it'll work is when you have a matrix like this and then a vector like this, matrix multiplication will take the dot product of the rows here along the column here. So it's going to take a dot product of A1, A13, A25 with B1, B5, B9. Then it's going to store that in an element, which is going to be this top element here. Then it's going to move down this matrix here. It's going to move down this array here, and it's going to take the dot product of A5, A17, A29 with B1, B5, B9. That's this second element here. And then it's going to do the same with this last one. And if it had more values here, if it had more rows, it would just keep going, essentially. But note that the way this works the number of elements in each row has to be the same as the number of elements in this column. If this contained something like B1, B5, B9, and B13, for example, it would give us an error because it would be trying to multiply, it would be trying to take the dot product of this row with this column. And because B in this hypothetical has 4 elements, it wouldn't be able to do that. But anyways, that's a way that we don't have to combine the individual dot products together, like stack them together. We can just do this all at once by using a matrix multiplication. And that's the way that we're going to get this first column here. Now these other lines here, you can take a look at them, but they're exactly the same process, just different values. Like this is going to be this second row, second column here. And now we have A2, A14, A26, which is here. And then the rest of these rows follow the same pattern. And B2, B6, B10. Now that's the B vector, which is being multiplied in each of these elements. It's B2, B6, B10, and that's in each of these rows. So like I said, we could construct each of these 4 columns and combine them together. But if you have a number of matrix multiplications, and then multiplying the same shape, because these A vectors or A arrays have all the same shape. It's 3 by 3. Being matrix multiplied by all these B vectors that have the same shape, you can actually combine them into one matrix multiplication. And all you have to do is just treat each of these elements here, which is this 2 by 2 array, treat those as an element within another axis. So we can just stack these vertically. We're not actually going to stack them vertically in terms of the functions that we use, but in the visual, we just stack them vertically. Add another dimension on the outside, and then that's going to be a new array of A's. And we just matrix multiply those with each of these B vectors just stacked. So we add another dimension, and each of these blocks here is going to be an element within that dimension. That's what I've written here. And again, pause it if you don't understand and think about it yourself. But now each of these columns here, each of these elements are now a block within this new axis here. So we've just added a dimension and stacked it vertically. And that's what I've done here with this A, and that's what I've done here with this B's. And now we can calculate this directly by just matrix multiplying this vector of A's by this vector of B's. So now there's just one matrix multiplication. And once we've obtained this, all we need to do is just transpose it or swap the axes in such a way to get this, because this is vertical, this is horizontal, but we can just fix that pretty easily. And the reason I've done it like this is because it turns out you can actually construct these 2 arrays here from the arrays that we're given. I'm going to show you how to do that. Let's take a look at A. This is A. What do we have? We have 1, 5, 9, 13, 17, 21, 25, 29, 33. That's the same elements down here. And then these elements down here are all here instead. So this column here is over here. And then the next 2 columns down there get repeated along here. So it's kind of swapping the axes around. That's what you can think. When you get the same elements or the same group of elements and they're just being moved around, you essentially can use the swap axes command. And sometimes you can even use the move axes command or the transpose command. And if we look at how these are being swapped, all right, the elements through axis 0, 1, 13, and 25 are now along axis 2 here. And now these elements, 5, 17, 29, those are along axis 2 as well. And they're right below the values up here. And now 9, 21, 33 are right here. And now when we move along one element to the side here, along this column now, along these columns now, we repeat the same pattern. So 2, 14, 26, we have 2, 14, 26, and so on. this is going to be a swap axis, and it's going to be a swap axis with 0 because we're taking the elements through the 0th axis, and now we're moving them through the 2nd axis like this. Because these elements are through the 2nd axis, through each row, and then these elements are through each block, through the 0th axis. That's what we're swapping around. We're swapping the axes around. So we can call numpy.swap axes A, and then 2 with 0, or 0 with 2. It's the same output, but this one makes more sense to me. All right, and now we have this result: 1, 5, 9, 13, 17, 21, 25, 29, 33. That's this one, and it repeats down here as well. We've got what we want. This is all we need for A. Now we need to construct B. We can get rid of that for now. Now what is B? Firstly, B has an added dimension. We need to add a dimension here, and we can do that with expand dims. And we add it at the 0th axis, which is the most outer axis. Okay, so we've got the added dimension. Now this is going to be another swap axes. We know that 159, that's 159, that's the same here. But how do we do this? All right, this 2nd axis here, each row, all the elements through the 2nd axis is now being moved to the 0th axis, or through the 0th axis, I should say. So we have 1, 2, 3, 4, that's through axis 2, and now it's through axis 0, 1, 2, 3, 4. And then 9, 10, 11, 12. Now it's 9, 10, 11, 12, and now that's through each block, which is through the 0th axis. So it's another swap axes, and this time it is, what did I say, 2 with 0. I mean, essentially 0 with 2 will work the same way, but you know, you can kind of, this is more intuitive to me anyways. All right, and we get this same result, and now all we need to do is just matrix multiply them together. We can do it like this, and this line here is equivalent to, I'll just show you. It's equivalent to this function, np.matmul, which is matrix multiplication. This is just a shorthand of writing it. So we've got this result here, and it's equivalent to this one. Now that we've got this one, all we need to do is just get this result here. And the only difference is a transformation of axes. It's another swap axes. This one, it looks like, all right, how do we think of this? Okay, so the elements within each, the elements through the 0th axis are now being moved through the 1st axis here. But note, so this output here doesn't have an added dimension. So when we actually move it first, this axis here, which is responsible for the rows, that's going to be the 2nd axis. And then what we need to do is we just need to squeeze it, which means remove the dimension. Because if we move the elements that are through the 0th axis, if we move that to the 2nd axis, then we're going to get this general pattern, but it's just going to have an added dimension. And then we need to remove that dimension. That's simple enough. So we can go swap axes, and we're going to swap axes, what did I say, 0 with 2. All right, we get this. And now what we need to do is just remove the dimension, and we can do that with numpy.squeeze. And, oh, that's it. So squeeze doesn't take in any other arguments, it just takes in the array. And it just removes all the dimensions that have 1, essentially. So if I don't do that, and then I just call dot shape, you can see that it's 1 by 3 by 4, which is, you know, there's a dimension here with 1 element. So numpy takes that away if you write numpy.squeeze. And then if I call dot shape, now it's 3 by 4. Okay, that's all we need. Let's test this out. Let's call this output. And let's just take a look at out. So this is the one that I calculated by hand. Now we will compare the two. So output is the one that we created, and we call numpy.array equal, and that will return true or false depending on whether the arrays are equivalent. And that returns true. That's how we do it. That is one way to do it essentially. And what you could do here is you can combine a lot of these functions, I imagine. Like there's multiple swap axes commands here, so you could probably combine those in such a way to make a move axis command. Actually, I'm not sure because there's a matrix multiplication here. But for example, okay, so we're swapping 2 with 0, and then 0 with 2, and then 0 with 2. So maybe some of these would be redundant, like if we're swapping 2 with 0, and then 2 with 0 here, and then we're re-swapping 0 with 2, maybe there's a way to do this without swapping the axes at all. Like I tried to do that, but I couldn't find a way. If anyone knows a way, then let me know in the comments. But thanks for watching.